Hey everyone, Dr. Walker again. In this video, I'm going to go over the one example from video 207, comparing the gravitational force and electric forces. It's going to be a brief example just to give you some numbers to work with. So let's take a look at the example. It says, find the ratio of the electric force to the gravitational force for an electron and a proton that are 0.53 times 10 to the negative 10 meters apart. And this is actually the distance between the electron and the proton in a regular hydrogen atom, so average distance. So basically all this question is asking is to figure out what's the electric force between the two charges, what's the gravitational force between the two charges, and just take the ratio, because the ratio tells you how much greater the electric force is than the gravitational force. Or it could tell you that it's smaller, but we learned in the previous video that the electric force is much stronger than the gravitational force. So what we're looking for is the ratio of these two forces. So we can go ahead and write down Fe for electric force divided by F sub g for the gravitational force, and then just plug in the definition of each force. The electric force given by Coulomb's law is Coulomb's constant times Q1, Q2 over R squared. And then we're going to divide all of this by the gravitational force, which is G, M1, M2 over R squared. Now, it turns out that when you are taking these ratios, if you can see that the R squared actually cancels out. You can see this if you multiply by the reciprocal. So let's take a look. KQ1, Q2 over R squared multiplied by the reciprocal, which is R squared over GM1, M2. So the distance between them doesn't matter when you're trying to find the ratio of the two forces. The distance cancels out. So what we're looking for is the ratio of these two right here. Let's just go ahead and plug in all the values that we know. So K is Coulomb constant, 8.99 times 10 to the 9. And then we need to know the magnitude of each charge. Remember, we're always putting the absolute value. I might not put it in there, but we're always using the magnitude of the charges when we're using this equation. So what is the charge of an electron and what is the charge of a proton? You can call this electron Q1 and the proton Q2. They both have the same charge. Remember, we learned that the magnitude of the charge was E, and E was 1.6 times 10 to the negative 19 coulombs. So whenever you need the magnitude of the charge of an electron or proton, it's always the value for E. So we're going to go ahead and plug that in. 1.6 times 10 to the negative 19, and then once again, because we have two charges, and then we are going to divide by big G here, 6.674 times 10 to the negative 11, and then the masses. So we need to know M1, right, the mass of the electron, and M2, the mass of the proton. So these are constants. We're given these constants in, I think, the first lecture, a little chart. So go ahead and find that chart and write down those values. The mass of the electron is 9.11 times 10 to the negative 31. And then the mass of the proton here is going to be 1.67 times 10 to the negative 27. And both of these are in kilograms, which is a standard unit that we need. So if we plug in all of these values, then we will get the answer that was in the previous slide, which was a really big number, 2.27 times 10 to the 39. So this really shows you how much stronger the electric force is than the gravitational force. It's this much bigger. So just wanted to provide a numerical example so that you could really get a good idea of the difference between these two forces. See you in the next video.